Find the slope of the tangent line to the graph of 3x squared minus 8x at the point 2, negative 4. Let's first just confirm that f of 2 actually does equal negative 4. Otherwise, we'll correct the y coordinate. F of 2 equals 3 times 2 squared minus 8 times 2. So that equals whatever 3 times 4 is, minus 16. That's 12 minus 16, which sure enough equals negative 4. So the point 2, negative 4 is on the graph, and it's just a matter of finding the slope of the tangent line at that point. So we want to find the limit as delta x approaches 0 of f of, well again, c equals 2. Sometimes it's a different number, but in 2 out of 2 cases, c has equaled 2. 2 plus delta x minus f of 2 all over delta x. So the limit as delta x approaches 0 is more work when it's quadratic. To evaluate f of 2 plus delta x, we need to substitute 2 plus delta x for x in both of the places in this quadratic expression where there's an x. So there's a 3 times an x squared, and there's an 8 times an x. And 2 plus delta x has to be substituted into each of these sets of parentheses. So we put it there. 2 plus delta x there. 2 plus delta x right there. Now we're going to subtract f of 2. And here, rather than, well, like putting something like this in parentheses and putting up there, I think it's far safer just to say, okay, we believe f of 2 is negative 4. So let's subtract negative 4. Calculate that separately off in the margin somewhere. Conclude that's negative 4, and then subtract that. All over delta x.
If we find that that's not negative 4, do we just plug in whatever value we get?
Yeah, just instructor error, and then whatever the value is. A lot of times it'll just say find the slope of the graph at x equals 2, and it won't specify the y coordinate. And that way, whatever it happens to be, that's what you use for the y coordinate. So we work on the numerator. And we keep working on the numerator until we can factor out a delta x or conclude that delta x is actually not a factor of the numerator. So we got to square the 2 plus delta x using the formula for squaring a binomial. We square the first term. Square the 2, we get 4. And then it's twice the product of the two terms. So 2 times the delta x is 2 delta x, and then it's twice that product, so plus 4 delta x plus, and when you express the square of delta x, it's customary to enclose the delta and the x in a set of parentheses. We really don't talk about what might be meant by the change in x squared. But it's not the change in x squared, it's the square of the change in x. That's what's denoted here. So it's customary to enclose that in parentheses. Minus 16 minus 8 times delta x as we distribute the delta x, as we distribute the negative 8 across the parentheses. And then minus a negative 4 is equivalent to plus positive 4, adding positive 4. All over delta x. Got to simplify some more, distribute the 3 across the parentheses, and I think I'll have room if I move it up here. The limit as delta x approaches 0 of 12 plus 12 delta x plus 3 times delta x quantity squared. We can go ahead and combine the negative 16 and the positive 4 to get negative 12, whether we want to put that before or after I'll go put it in place of where the 16 was. Say minus 12 minus 8 delta x all over delta x. Now, if we combine the 12 and the negative 12, of course, those add to 0, so those cancel. And then we're left combining the delta x terms. So this equals the limit as delta x approaches 0 of ordinarily we put the squared term first. So I'll go ahead and do that. 3 times delta x squared plus 4 delta x all over delta x. So, is delta x a factor of the numerator? It is. It's a factor of each term of the numerator. So we can factor the delta x out of the numerator, writing it limit as delta x approaches 0 of delta x times 3 delta x plus 4 all over delta x. We can then divide out the delta x's. Again, that's the point. We want to be able to divide the delta x out of the denominator so that we can evaluate this by direct substitution. So this equals the limit as delta x approaches 0. Divide out those delta x's, and we have 0 3 delta x plus 4. Finally, the denominator is no longer going to 0. So we can evaluate this by direct substitution. Substitute 0 for delta x, and it's going to be 3 times 0 plus 4, which is 0 plus 4, which is 4. So the slope of the graph at this point, the slope of the tangent line, and it's 4. I'll try the standard viewing window. The point 2, negative 4 is in the standard viewing window, and maybe that'll work for us. Zoom 6. Not bad. 2, negative 4 is right down there. If we were to draw, I think I can improve on it though. There's wasted space to the left and to the right of where we see the graph is. So I think if we go with an x-min of maybe negative 2 and an x-max of 4, we'll see the curvature of the graph a little bit better. Let's try this instead. X-min equals negative 2, x-max equals 4, and try this graph. There we go. So as we look at it and see what's happening at the point, second calc value, x equals 2. There's the point. And if we look at the slope of the graph, now at this point, what I've done, I've modified it in such a way that the scale on the x-axis is considerably different from the scale on the y-axis. Nonetheless, if I think about what's going to happen as I go 1 unit to the right, then I think it's reasonable to think that I go about 4 units up right there. Be nice if we could get the calculator to display the slope, the graph of the tangent line. If we know a point on the line, 2, negative 4, and we know the slope of this line, can we write an equation for this line? Problem didn't ask us to do that. It's like extra work at this point. But I think that it would be good as far as the visual is concerned. If I can find some room on here for the equation of the tangent line, y'all know from somewhere y minus y sub 1 equals m times x minus x sub 1. Point slope form. Well, we've got a point, we've got a slope. So y minus negative 4 equals the slope 4 times x minus 2. If we solve this for y, put in slope-intercept form, then we can just type in the right-hand side, and the calculator should graph this for us. So y plus 4 equals 4x minus 8, so y equals 4x minus 12. if we had the calculator graph this line, it should kind of look like it's behaving as the graph is behaving and going right up alongside it, the tangent line. So here goes. Y equals 4x minus 12. That look okay at the point 2, 4? 2, negative 4? That seems all right.